All right, welcome back, Algebra 1A students. We got another video here for you. This one, we're still working on the practice test for topic 2, covering exponents, version 1 of the practice test. But this video, we are going to cover the second page, 10 through 15. So our instructions for 10 through 13 say we're going to give the sign of each expression, explain how you know. So we're kind of set up for the sign to either be positive or negative. We do not have to evaluate, meaning we don't have to perform the repeated multiplication or division, but we just have to say if it would come out positive or if it would come out negative and give a reason, give an explanation. So number 10, we have negative 8 to the 194th power. Now we could, if we want to, try to write out, the expanded form. Start with your positive 1. This is a positive exponent, so it would be multiplying by the base, multiplied by negative 8. 194 times. Oh boy, I don't know about you, but I do not want to write out the base 194 times. So I'm just going to kind of put ... here. It would keep going. Well, with the negative base, it is possible that I'm going to keep multiplying with these negative 8s. It's possible that I could come up with a negative result. But because we know that when we multiply or divide, our negatives come in pairs between what we're multiplying or dividing with and the answer we get. We need an even number of negatives. Well, we have an even exponent. So that means when I write this all out, I will have an even number of negatives. So every negative will have a buddy, and my result will be positive here. So you might say that. You might kind of write it out there. We're going to have an even number of negatives. 194 is even. And maybe the quickest, easiest way that I could explain this is just the kind of the rule that says when you have a negative base to an even exponent, the result is positive. That might be the best way that I could explain this. The quickest, simplest, easiest way to explain that. So number 10 is going to be a very, very large number, negative 8 to the 194th. I am not evaluating it, but I am saying that whatever it would come out to would be a positive number rather than a negative. Negative base with an even exponent gives you a positive result. Number 11 is similar here, negative 93 to the 73rd power. Again, I could, if I want to, try to start writing this out. 1 times the base of negative 91. It's a positive exponent, so it would be repeated multiplication. But I'd have to do this negative 91 73 times. And again, I don't want to do that many times. But in this case, we have an odd exponent. So negative times negative is going to give you a positive. Another negative times negative is going to give you a positive. But because 73 is odd, there's going to be a negative left over. An odd number of negatives, odd exponent, odd number of negatives, and there's going to be a negative left over. A negative will need a buddy. And so that's going to make, let me finish writing that out. A negative will need a buddy. That's going to leave us with this result. Again, I'm not going to calculate it because it's going to be a ridiculously huge number, but it's going to be a negative result here. Again, maybe the quickest way to explain it here would be to say something like a negative base with an odd power, an odd exponent, will give you a negative result. That's maybe the quickest way that you could explain that. And feel free, if you like that shortcut, to say negative to an even is a positive result, negative base to an odd exponent is a negative result, and you can forget about the exponent being positive or negative. So number 12, we have that now. I've got a negative exponent, but remember, the exponent doesn't show up as a number to operate with. Number 10, even if I wrote everything out in number 10, 194 doesn't show up as a number to operate with. It's just that I'm doing something 194 times. Number 11, 73 would never show up in the operation. It's just that I would do something 73 times. So even though here the exponent is negative, it doesn't mean that it's like a negative times a negative 23 times a negative 48. No, this would be if I wanted to write it out. I could do, I'll do the reciprocal here. So multiply by the reciprocal of negative 23. So the negative 48 as the exponent will not show up as a number to operate with. It's that I would do this 48 times. I would do 1 over negative 23 48 times. So it boils down again to it's an even exponent, and we've got a negative base with an even exponent. Every single one of these negatives would have a buddy with an even amount of those negatives. So that's going to give us a positive result. We'll come over here and we'll circle that. So again, just to explain it, we would have 48 of these negatives, and I could make pairs of them. 48 is an even number. Every negative would have a buddy. So again, I'm not operating. This would end up being a very, very small number technically, 1 over whatever all those negative 23s multiplied would give you, but there's an even amount of those negatives. So every negative has a buddy, positive result. Okay. The last one before we get to 14 and 15, the last one in this table, here this one is maybe deceptively simple because that negative might throw you off, but if you think about it here, if we're going to write out the expanded form, start with a 1, and, well, the negative exponent just tells me I would do the reciprocal. I would either divide by positive 216, or I could multiply by the reciprocal 1 over 216. So again, the negative 15 does not show up in the operation. It's I'm doing something 15 times. The negative means I'm either dividing or I'm doing the reciprocal 15 times, but it's a positive base. There are no negatives to be seen here. Again, the negative exponent just means I'm either dividing or multiplying by the reciprocal. With the base being positive, this is going to come out positive. And if you like these shortcuts where a negative base with an even exponent is positive, negative base with an odd exponent negative, here you can just say a positive exponent with, a positive base with any exponent, even odd, I don't care, you're going to get a positive result. So even a positive base with a negative exponent, it's going to be a small number, but it's a positive result. Okay. All right, so that's it for that section. Yeah, so knowing those shortcut kind of explanations is nice, but if you forget, you might think about what would it look like if I write out the expanded form. All right, a couple more for this page, a couple more for this video. 14 and 15 says we're going to use the fact that 11 to the 4th power is equal to 14,641. So we're being told that. We don't have to calculate that. That's a given. But that's supposed to help us now with number 14. 14 asks us, what is the value of negative 11 to the 4th power? So the value means like do the operations, evaluate, calculate, give me a number. Just a single number, no operations. Well, let's think about this here. Negative 11 to the 4th power would mean in expanded form, start with a positive 1. It's a positive exponent, so I can write and multiply with the base 4 times. So let's see here. I know that this is going to come out positive. We could go back up to what we did up here. A negative base with an even exponent, 4 is even, is going to be a positive. But the question is positive what? I'm not allowed to use a calculator on this test, so, oh boy, 11 times 11, that one I can do, that's 121, times 11 again, and times 11 again. Well, the nice thing is, because I've already been given the fact that 11 to the 4th is that 14,000 and change, I don't have to perform these operations. This right here is 1 times 11 times 11 times 11 times 11. And so it's 4 bases of 11 multiplied together. So if you remember, the trick with multiplication is you multiply a bunch of 11s, I'm still going to get the 14,641. The only question is with these negatives, would it be a positive 14,000 or a negative 14,000? And we already talked about that. You could even either say it's a negative to an even exponent, or this is not bad to write out the expanded form. We could say every negative has a buddy. And so we're just sitting at positive 14,641. Okay. One more for this page, one more for this video. Again, we're still using this 11 to the fourth is that 14,000, but this time we have a negative exponent. Same base of 11, but with a negative exponent. So that means I am going to divide or multiply. I'm going to do multiply by the reciprocal for that negative exponent. So that'll be start with a positive 1. But then either divide by 11 or multiply by the reciprocal 1 over 11 4 times. So again, the negative 4 is not showing up in the expanded form. It's just I'm doing the reciprocal 4 times. Reciprocal because of the negative exponent. Well, let's see here. Multiplying these fractions, the numerator would just be a 1. In the denominator, oh, I don't get to use a calculator, but it'd be 11 times 11 times 11 times 11 in the denominator. And you might go, well, wait a minute, we did that already. We had that up here. That was the given, 11 to the fourth. So it's 1 on top and then that 14,641 on the bottom. And there you go. That's it for number 15. If you wanted a shortcut for number 15, you might remember there's a property that says if you have an exponent, a negative exponent rather, the shortcut is to say put that as a positive exponent on the bottom of a fraction. So 1 over x to the positive m. So we could say 11 to the negative fourth would be, 11 to the negative fourth would be 1 over 11 to the positive fourth. See if I can write this nicely. And so we can just kind of insert then that 11 to the fourth is that 14,000, but it's on the bottom of the fraction. So hope that video helped, and see me in the next one.